Hello, everyone. I'm Mike Efron, the director of Under One Roof, and I want to welcome you to this webinar on clean heating options for tenements. Today, we are looking at the issue of people that own tenement flats, and don't know where to start, basically, when it comes to looking at the different clean heating options that exist. Today, we've got Chris Karras, who's the managing director of Loco Homes, and Chris is as managing director of Loco Homes Retrofit. It's a Glasgow-based cooperative of householders, contractors, and advisors focused on promoting energy efficiency within our homes, tackling the climate crisis, and keeping energy bills affordable. So, welcome, Chris.
Thank you. Good to be
here. So just a little bit about us. So if you're not familiar with Under One Roof, we are a charity dedicated to providing free, impartial information on repairs, maintenance, and retrofit for tenement flat owner occupiers and landlords, and also housing professionals in Scotland. We've existed for about 4.5 years, coming up on 5 years now, and we try to provide as much free information as we can and support on organizing repairs, all the different elements of that, but also looking at not just repairs, but retrofit of tenement buildings as well. We do a number of webinars such as this, and like all of our webinars, what we'll be doing is having Chris, he'll be giving a presentation, and he'll talk through the agenda in a second. And then there'll be opportunity for people to ask questions at the end of the webinar. And so we've got two things. We've got a chat room. If you look at the top of your screen, you should see chat. That's just a general sort of for putting in information. I'll pop in some links over the course of the webinar in there about various things Chris is talking about. We also have a Q&A chat room. So if you have any questions, you can pop your questions in there throughout the webinar, and then we'll turn to those at the end. We're probably aiming to go for about an hour or so. And Chris has a lot of information to provide. So he's going to talk us through some of the best clean heating options available for tenement owners today, the challenges of installing new cleaning heating systems, and how to resolve them. So, Chris, I'll hand it over to you and take it from there.
Great. Thank you, Mike. So let's get the agenda up. So we're going to start by looking at some of the context for why we need to be thinking about clean heating, what the government policy is or how it's developing, and regulations. We'll look at the options that are available to flat owners in a bit more detail, and also the question of building fabric, very important to Under One Roof with regard to repairs and maintenance and where clean heating fits into that sequence. And also we'll look at some options that people can take in the short term. So the first reason that clean heating is on the agenda at all is climate change. So this picture here is from a wildfire in Scotland a few years ago that ran out of control, and it's brought on by these longer, warmer, drier spells that we're getting in Scotland, leading to Scotland being a country that has wildfires. And we know that globally the climate is changing. We know that overall the world is warming. We know that it's caused by us. The science on this is beyond any doubt or question now. And we're sure it's going to get worse until we end the burning of fossil fuels. It's very bad. So although in Scotland we don't see droughts and famines all the time, but to the same extent as other parts of the world, this is partly because the effect of global warming is quite weird. Catherine Hayhoe, the climate scientist, says a better word for climate change is global weirding rather than global warming, because the effects of climate change are different in different parts of the world. In the North Atlantic, the ocean is actually cooling because there's so much cold water coming from the Arctic as it melts and that's actually having an effect to cool the North Atlantic and having an impact on our weather. But long term, we can expect to see stronger storms, more intense rainfall, windier storms, which will have an effect on our buildings, and impacts around the world on agriculture from droughts and harvest failures, and ensuing refugee movements. So it's a huge problem, but we can stop it getting worse by ending the burning of fossil fuels. If we look at Scotland's progress so far, this is the emissions from burning fossil fuels in homes in Scotland over the past almost 20 years. And there was some gradual progress, mainly driven by introduction of insulation, but that kind of flatlined from about 2014, which is when the UK government cut the green crap, as David Cameron said back then. So insulation programs were much smaller after that point. But there's a big drop in 2022. This was not due to clean heating. This was the number of gas meters being existing in Scotland was still increasing through that period. What's happening here is the impact of the war in Ukraine and the embargoes on Russian oil, which means that prices went up and people are now using less gas as a result of that. So really, so far, we're not really having an impact on emissions from using gas unless the price goes up and people end up with colder homes. So that's not sustainable. Electricity in Scotland is now very green. So while you'd create about 200 grams of CO2 from burning 1 unit of gas for heating, and a unit of electricity in Scotland, generated in Scotland, only produces around 20 grams of CO2. So electricity is much greener, and if we can switch our heating to electrical systems, then we're going to make a massive reduction in carbon emissions. Now, there are questions about the price of electricity, and I'll come on to that. The other reason is that we have yet another, tragically, fossil-fueled war going on right now, only just a few years since the last one, and that's cutting off 20% of global oil supply. And the only way to get out of these problems is to move away from oil and gas, end our dependence on oil and gas. People say, oh, well, wind power is no good if the wind isn't blowing, and solar power is no good if the sun isn't shining. Well, oil and gas doesn't work if the Strait of Hormuz isn't Hormuzing. So we need to move away from oil and gas to be independent and have our own energy security. Clean heating systems often come with a package of retrofit measures. Now, there's no need to improve insulation when moving from a fossil fuel heating system, such as a gas boiler, to a clean heating system, although it will make the system less expensive and smaller in terms of its size and the invasiveness of the changes to radius of pipework. But it also comes with a package of retrofit measures, including insulation and draft proofing, and good ventilation has benefits for comfort, health and air quality, lower bills, and there's emerging evidence that clean heating upgrades and retrofit upgrades will improve the property's value. So there's lots of reasons why we should be moving as a country towards clean heating. But in flats, it's particularly difficult. So I'm going to be going through how this looks for people in flats who face greater constraints in terms of cooperation with neighbours as compared with people in houses. So in terms of the context, in terms of policy and regulation, this is an area that's devolved to the control of the Scottish Government. And the Scottish Government previously was considering introducing requirements to move to clean heating, to move away from fossil fuel heating. That's now been abandoned with the heating building strategy of 2023 now discarded. There's now a target of moving to clean heating by 2045. And the plans for that are going to be developed subject to the outcome of the election in a new heating building strategy and delivery plan in 2026. The Scottish Government has put out a draft heating buildings bill, which includes some provisions for private rental sector, energy efficiency, so not clean heating, and provisions for heat network regulation to support consumer protection and investment in heat networks. But that's the extent of regulation as it applies to to clean heating. There's nothing, and it's only a voluntary program. The Scottish Government said they have no intention of introducing a requirement for people to move to clean heating. There's one change where we are expecting to see regulation. That's the private rental sector minimum energy efficiency standards. In the most recent consultation, I think there have been 6 on this topic now. The plan is to introduce requirements only for insulation levels, what's called a heat retention rating. And this means that instant electric would not be penalised despite its high running costs, which I think is which has its downsides, obviously. So instant electric heaters are cheap to install but expensive to run. So it's yet to be seen how regulations will emerge in all these sectors. Heat network regulation is moving ahead. There's a legally binding target set by the Scottish Government to move to 8% of heat demand being supplied by heat networks by 2030, up from around 1.5 or 2% today. So a quadrupling in the size of the heat networks in the next 4 years, which is an ambitious target. And we can have our views about how realistic that is, considering the current pace, but it is necessary to meet the Scottish Government's legally binding targets on carbon emissions. There is emerging, so there are improving regulations. The body of regulations to protect consumers is improving between efforts made by the Scottish Government and the UK government. So there's now, since the beginning of this year, better protection for consumers around complaints, billing, metering, and the technical standard or service standards that people should expect from heat networks. And there's also licenses. Powers are being introduced to require the operators of heat networks to have licenses to show that they are fit and proper people to operate heat networks. And there's also efforts being made to make heat networks more investable, because huge amounts of capital need to be brought in to build these networks of buried insulated pipes connected to each building. So that means establishing zones and then establishing permits for the development of networks in zones. So it's clear who is getting the customers in that area and what their obligations are on those developers. So each local authority has now been given the responsibility from the Scottish Government to develop local heat and energy efficiency strategies. And if you're confused about what to expect in your building, then this is the first place to look. So here's some examples from local authorities across Scotland. In Fife and Dundee and Edinburgh, there's an interactive map available, and in other local authorities showing the likely extent of areas which are suitable for heat networks. Doesn't mean they're necessarily going to build a heat network there, but it does mean that that area is highly suitable, and some areas are of lesser suitability. And it's all to do with the density of heat demand. So is it worth building a network, and the proximity to clean heat sources, which for heat networks principally means river source or water source heat pumps or sea source heat pumps, or from energy from waste plants. So burning biogas produced from the anaerobic digestion of organic waste. So there's a few of those around the country. In some local authorities, it's more of a description of where they expect to see the heat networks, and that's the Highland one there. So local heat and energy efficiency strategies can be found on your council's website, and it will indicate to you whether or not you are in an area that's likely to get a heat network. However, as I said, it's not clear how long it's going to be until these heat networks are in place. What we're talking about here is thousands of miles of insulated pipes to be buried under pipes to be buried under thousands of miles of streets all across Scotland at the same time as the same is being done in England and Wales and across Europe. So it's an absolutely gigantic infrastructure project. It's not clear what the times will be, considering the availability of both money and labour. You know, who are the people to go in to do this? So it might be that your heating system, whether it's a gas boiler or an electric system, is going to reach the end of its lifespan before a heat network comes, and you might have an opportunity to make some changes that would reduce your bills and improve your comfort. So there is funding available, the last part of the context. So from Home Energy Scotland, there's a grant and loan scheme for air to water heat pumps. There's funding for heat network connections, and that's £7,500 grant increasing to £9,000 in rural areas, plus the option of £7,500 of interest-free loan. And there's also the option to upgrade to high heat retention storage heaters, so modern, more controllable storage heaters with a grant and loan of a smaller size, but still significant compared to the cost of those measures. There's also fuel funding for those in fuel poverty through the Warmer Homes Scotland, so that's means tested, whereas the Home Energy Scotland grant and loan is not means tested. It's available to all homeowners. Local authorities also have neighbourhood focused schemes which are mainly focused on insulation and sometimes solar panels, but may include heating in the future. There's interest-free loans for landlords available through Home Energy Scotland. And for developers, there's a heat network fund offering substantial funding for the capital cost of developing heat networks. Okay, so, oh yeah, and I will say that we went into some more depth on the grant environment for heating and insulation with Home Energy Scotland in a webinar, which is now on the YouTube YouTube channel for Under One Roof. You can find more there. So going to options in more detail. So principally, we're talking about individual options, which break down into resistive electric heating options, such as storage heaters, or individual heat pumps, or as I said, heat networks. Here's an example of buried or insulated pipes about to be buried under a road. So in resistive electric, what we're talking about here is the same technology as you have in your toaster or kettle, which means passing electricity through an element to generate heat. And these come in different forms. These can be either supplied instantly. So this would be electric panels that at a flick of a switch start generating heat. Infrared panels is basically the same technology, but running at a lower power for longer periods. Infrared is marketed on the basis that it saves energy because you don't heat the room, you don't heat the air. So you direct the panels at where people are going to be sitting or sleeping. And therefore you heat the people or one side of the person, and therefore the air is colder, the building is colder, and therefore the heat loss is lower. There's a real lack of robust evidence to support the claims around infrared energy savings. There's no real literature on this, and there was a UK government literature review which confirmed there's really just a lack of evidence about that. And there's also the concern that with cold air, vulnerable people, so elderly people, people with health conditions, will be vulnerable to respiratory health problems if they're living in cold air for long periods. There's also electric boilers, some which have a little bit of storage, and there's instant electric hot watering, instant electric heating, which is essentially an element in the pipe for space heating and hot water for the taps. So that's extremely expensive to run because you're running on the peak rate, which might be 25, 30p per kilowatt hour versus 6 to 9p for gas. So much, much more expensive. The edge on that, the price difference can be taken off if you can use an off-peak rate with indirect resistive electric or storage heating. So that's typically, this is a high heat retention storage heater, a modern storage heater, which works the same way. It has sort of ceramic blocks that store the heat overnight and then release the heat over the day, and can be topped up if you have a smart tariff with off-peak electricity mid-afternoon, say ahead of the evening. And the control by opening a flap, which controls how much water or how much air is moving through or across the storage element. There's also now storage heaters that work with wet systems, so with water-filled radiators. And this is essentially a massive storage heater that sits in a cupboard somewhere, heated to extremely high temperature, and then connected to the pipework of your hot water of your space heating system, the radiators. This can be they're very expensive, very heavy. This is the issue with them, is they're very heavy, which can be a consideration for getting them into flats, and also whether or not you may need to strengthen the floor joists to hold that weight. There's also, I don't have a photo, but there's now electrical storage systems where you have an electrical battery, a large electrical battery, somewhere in your flat, connected to your wet heating system, so the pipe work for the radiators, and an element is providing heat instantly from the electrical storage. So you're charging it with off-peak electricity, or perhaps from solar panels if you have access to solar panels in your flat, and heating the water for space or for taps as and when you need it. This is quite an emerging technology, and I don't really have much experience with it. So Individual heat pumps is the next one to look at. So this is where we're using a refrigeration cycle to transfer heat from the outside environment to indoors. And with this technology, it's common to achieve 350% efficiency, so 3.5 units of heat for 1 unit of electricity, provided you've got a good system design. So good system design means the right size of the heat pump, right size of radiators, right size of pipe work, the right controls for the system, and a good handover so the user knows how to control that system. So it's quite difficult to get that's all the stars to align on a good heat pump system, but it is becoming more common. So if you can locate them, they are an option for flats. If you find somewhere to put the heat pump, if you can, so if the efficiency of the system will overcome the price difference between electricity and gas, and if you can use a time of use tariff to top up space heating and top up and to reheat hot water storage off peak, then you start to make a saving, sometimes quite a significant saving, and you eliminate the standing charge for the gas meter if you get rid of the gas meter. So a quick word on the language around this. So the source of the heat may be from air or ground or water. And so you might say, I've got an air source heat pump. That means that the heat is coming from the outside air, or you might have a ground source heat pump. And the emitter, so how the heat is being delivered into the property, might be through water-filled radiators, or it might be through air. So a heat exchanger warming up the air directly with a fan coil and a fan moving that air around inside. So then you'd have an air source heat pump, may be air to water, so air to water filled radiators, or air to air, like a fan basically inside. So that's just on the language. Here's some examples of individual heat pumps that we've seen installed in flats in Scotland. So first is an outdoor located air to water heat pump. So it's using the outside air to heat water supplied to the building through pipes. It's located outside. The hot water is coming from this system. So the system will, and the hot water is in a storage cylinder indoors. It can be certified to the MCS standard. So MCS is the Micro Renewable Certification Standard. And this says that the equipment is of an appropriate standard, the installer is trained and qualified and experienced to an appropriate standard, and that the particular installation has been done to the required standard. So it's a kind of an assurance that it's meeting a standard. This system is funded by Home Energy Scotland, so that's the £7,500 grant and 9,000 in rural areas. And it's good if you've got existing radiators and you can find somewhere to locate the heat pump, which might be, this is a ground floor tenement flat, so it's it's attached to the wall, but it's at ground level, or you could maybe put it on a balcony. There are also an emerging number of, or an increasing number of air to water heat pumps that can be located indoors. So this is an example of a flat where it's about as tall, well, it's a very tall fridge freezer. It's a bit taller than a fridge freezer, and it's a bit not quite as deep as a fridge freezer. It's in a cupboard, and it's using vents, drawing air through vents at the bottom. So 200 mm holes, this sort of size, drawing air in, extracting the heat to heat up hot water, and then discharging the chilled air through two of these 200 mm holes at the top, and they're sitting on top of a hot water cylinder, so everything's in that cupboard. It is MCS certified, it is Home Energy Scotland funded, and it's better if you've got no outdoor space. Now, whereas typically an air to water system with an outdoor unit we're seeing prices typically 15, 16, 17,000 pounds for owner occupier properties outside of the big schemes. So if you're back getting your own, procuring it on your own. Indoor systems are tending to be a bit more. So I heard about one last week that was £20,000. A third kind of air to water heat pump is where the heat is coming from extract air. So it's connected to the ventilation system, and so every property needs to discharge stale, smelly, moist air, but it's carrying a lot of heat because it's being heated. If you can extract that heat into the heat pump, then you're reusing that heat basically. This is air to water. It's storing water in a hot water cylinder. It's located indoors. It is MCS certified, but unfortunately, it's not funded by Home Energy Scotland. This is a bit of a confusing picture because we have had one funded by Home Energy Scotland, but the message now is they're no longer funding air to water heat pumps, exhaust air. And then the fourth kind I've got on the slide is air to air. So that's where there's, in this case, a cylinder, a unit outside, a fan unit outside. This one's located on a balcony, and it's supplying heat through refrigerant, so skinnier pipes carrying refrigerant rather than water, to these indoor units. And in this flat, it's wall-mounted units near the ceiling level with a fan recirculating air, the indoor air, over a heat exchanger. And there's other kinds of emitter which I'll come on to a bit later. These are not MCS certified, although the MCS is working with UK government to develop a standard for air to air. It's not funded by Home Energy Scotland. However, it's a lot less expensive. So it's in the range of £4,000 rather than 14 to 17,000 pounds for an air to water. So much more affordable. And I don't really understand why it's so much less expensive. I guess it's because we don't have to worry about pipework and radiators. Okay, so when you're getting an air to water heat pump, it is often necessary to upgrade the system. So the system means not just the heat source, but also the pipework and the radiators. And that's because one, for the heat pump to operate most cost efficiently, it needs to operate at a lower temperature. And for a radiator to give out as much heat at a lower temperature, it needs to be bigger. It needs to have more surface air. So instead of going from, so this in this flat, there's a double panel radiator. Now it's a triple panel radiator, which isn't quite as long, but it is fatter. So this, you need to watch it, the door can still close. And the pipework, because the pipework, the heat pumps work a bit differently to boilers. The water needs to go around the circuit faster. So you get more laps of the circuit to get the same amount of heat. And so to avoid noise issues or problems pushing the water through those pipes, the pipes may need to be a bit fatter. So that means 15mm typically instead of microbore. But not all. Sometimes pipework does not need to be changed. So it can be quite disruptive. And here's some examples of individual heat pumps in a flat. This is air to water heat pumps located outside a traditional tenement flat, which has had a lot of insulation added. So the heat pumps are quite small. So these are 3 kilowatt heat pumps, whereas typically you need 7 kilowatt heat pumps for a traditional tenement. 7, 8, 9 kilowatts for a traditional tenement flat. So a single fan, but a bit bigger than that. And there's questions about where can you locate it? You can put it on the ground, but you'll need neighbors' permission. You can hang it on the wall, but there's questions around whether you can access it for servicing. And there's permitted development and there are planning rules for one heat pump per property. So beyond one, you'll need to apply for planning consent. There's also questions around noise. So heat pumps are generally quieter than the noise that comes from the gas flue from a gas boiler. But if we've got several heat pumps, there are questions about noise, and planning departments do apply consideration to noise if you have to apply for consent. You do have to apply for consent if there's more than one heat pump, but you don't need to apply for consent if there's more than one boiler. Here's an example of an air-to-air system. So this is a system that can supply different kinds of emitters. These are space heating systems. So there's a cassette mounted high on the wall, like I showed before. There are other kinds of cassettes that can be inset into the ceiling. And there's a variation that looks a lot like a radiator, like a normal sort of water-filled radiator. And also with this system, you can have the hot water heated by the heat pump. Good question about conservation areas. So it's still possible to get heat pumps located in conservation areas. And I think permitted development rules it's the same for conservation areas, one heat pump per block of flats. More than one, you'll need to get planning permission. If you're in a listed building, different story entirely. You will definitely need to apply for consent. If you want to read more about air to air, there's a really excellent report that came out from the charity Nesta quite recently. This is very valuable because the evidence around how air to air systems perform and what skills are needed and what's needed for good outcomes is still quite weak, even though air to air is the most common heating system in most common heat pump system in the UK, but in commercial settings. So in domestic settings, we're still learning, and there's a good report there from Nesta. For hot water, um, you you know you there's direct like the resistive electric, which electric shower, or you can have indirect resistive electric for hot water cylinder with an immersion. So I think most of us would be familiar with that. And then, or you can have it from the heat pump, which would be a cylinder of some kind. And there's an increasing number of options for small um, storage solutions which are good for small flats, which are often smaller than houses. So here's an option which fits under a kitchen counter in a kitchen cupboard. So going back to heat pumps, first I'll talk about network ground source, which is something of a hybrid between an individual heat pump and a heat network. It's also called a fifth generation heat network. And in each flat, there's a water-to-water heat pump. This is a hot pump. And bottom right is on the floor is a heat pump. It's supplied by by ground temperature water from a network of boreholes in the nearby area. This is in a rural setting, but it could be in the back courts or in the streets. And there's a hot water cylinder because the system can't supply hot water instantaneously. And this system is good for areas that are outside where the main heat networks are proposed to be developed, and they're viable at a much smaller scale. It's said to be viable from 50 properties. If you're connecting to let's say it's called a fourth generation heat network, so this is where you've got the big insulated pipes under the street, probably driven by the local authority as a sort of municipal infrastructure project. What you'll have in your flat is something like this, which is called a heat interface unit, and that interfaces your heating system with the district network. So the district network is bringing water at 60 or 70 degrees, and it needs to transfer the heat through heat exchanger to your heating system. In this system, because the water is coming in so hot, you don't need local hot water storage. You probably won't need to upgrade radiators, however, there's a caveat, which is that most homes, the radiators are undersized for comfort. So on a cold day, most properties have at least one room where the radiator isn't big enough to supply enough heat. So you may want to upgrade radiators anyway, just for comfort levels. You won't need to upgrade pipework, but as I said before, cost and timings are not yet clear, and it's most likely to be limited to town centres, city centres, and large campuses around anchor loads like hospitals or schools or universities. So lots of people will be outside of those target heat network developing areas and will need to look at other options in flats. So quick question, a quick moment, quick word about building fabric upgrades. So the general advice on fabric is repairs first. So often you'll hear the term fabric first when we talk about the energy transition. I think the real meaning of this is maintenance first. So make sure repairs and maintenance are up to date. There's no point adding expensive systems to properties that are falling down. And if we add insulation, we don't need to add insulation to make heat pumps work. We're remarkably comfortable by putting boilers into uninsulated buildings, despite all their problems with climate change and energy dependence. But if you do add insulation before getting a heat pump, then the heat pump itself might be a bit smaller, less expensive. You may need to, you may be able to avoid some radiator and pipework upgrades, and you will be more comfortable, which is kind of a benefit on its own. Eliminate draft, so draft-proof everything that you possibly can, but replace at a certain point, to avoid the risk of damp, you will need to introduce some controlled ventilation, which means mechanical ventilation of some kind, usually an extract from kitchens and bathrooms. So, but the key point that I think Under One Roof would particularly want to reinforce is maintenance first. Think about the structure of the building and make sure it's going to last. So in the short term, what can people do? So you may not be able to get a heat pump, you may not want to get a resistive electric system, and you may want to wait for the heat network to come to your area. Or you may want to see for plans for heat networks to become clearer before you make any decisions. Now you can take steps to improve your comfort, your health and well-being, and reduce your bills in relation to your heating system. So first, obviously, insulation and draft proofing will reduce the amount of heat you need, but you can also take steps to minimize how much hot water you use. This is one of the easiest steps, and that can be having a low flow shower head, which is similar comfort to a normal shower head, but a lot less water, a lot less energy. If you have an electrical system, you can take advantage of off-peak tariffs. So make sure you're using the best off-peak tariff, whether it's an Economy 7 type tariff with a dedicated meter or a smart tariff with a smart meter. And the last thing I'll mention is you can optimize gas boilers. If you have a condensing type gas boiler, you're probably your condensing type boiler, which will be marketed to you as super efficient, is probably not operating in efficient condensing mode most of the time. So condensing mode means the water is going back to the boiler cool enough that it can take the heat out of the steam produced when you burn gas. So rather than have a big cloud of steam outside your flue, outside your property, that heat is being captured into your heating system, and instead liquid water drains out of the system. So there's three main steps to that. The quick one is reduce the operating temperature of your heat net of your boiler by just turning the dial that's on the boiler. So there'll be one for the taps and one for the space heating. By the way, this is only for combis. So if you have a hot water cylinder, you probably should not mess with this because you may have an issue with this sterilization of the hot water in the cylinder. So if you've got a combi system, reduce the flow temperature to as low as you can before you start having comfort problems, and you'll be able to turn it down further in milder weather. You may turn it back up in colder weather. If you don't want to be fiddling about with that all the time, you can get controls that automatically compensate for how cold or how mild it is outside. And you may find that radiators are undersized. So these column radiators have become quite fashionable, but their heat output is quite low. We looked at a flat recently, 150 square meter flat, where they were going to save £247 per year if they could upgrade their controls and their radiators to get their boiler to work in condensing mode. So that's something you can do now. So in summary, the drivers are climate change, bills and comfort for clean heating. Regulation is still emerging, but there's no requirement to change now. Your local authority's LHES, or Local Heat and Energy Efficiency Strategy, will give you direction as to whether you are located in an area likely to get a heat network. But the timings are unclear. You may want to take action individually while you wait for heat network, and there are options. And in the very short term, you can optimize your boiler. So that was my quick summary. I've not really been looking at the questions, but I'm going to stop the slides now and take some questions. Mike, have you got any questions?
Yeah, we've got one. Somebody, Tasman just came in and said, "Does permitted development apply to conservation areas?"
Yeah, so I tried to answer that as I went, and there's so if permitted development does apply to conservation areas. So the rules were relaxed in 2024, and I'm fairly sure that if you're in a conservation area, you are permitted to have one heat pump outside a block of flats.
Okay, great. Yeah, and I know you touched on it a little bit earlier, so I just wanted to make sure you got a full chance for that. And David asked if EPC regulations are planned to change based on insulation, not heating system. What typical measures are required to meet the proposed standard?
So the latest, this is for the private rental sector. There was proposals to introduce standards for energy efficiency. And the most recent proposals from the Scottish Government, and as I said, there have been quite a few variations on this over the years. The most recent one is to base the requirement on heat retention. So how much, basically the level of insulation in the walls, floor, roof the standard of the windows, and that'll be based off the EPC. Now, there's a lot. This is a moving feast because the way EPCs are reported is going to change. That's now postponed. Well, yeah, that's now postponed. There's the way that the EPC is calculated is changing. That's postponed to late 2026. And the also the standard, we're not clear what the standard is going to be. So the government was saying, Scottish government was saying they're trying to pitch the standard such that 80% of flats will not need to do anything. 80% of properties will not need to do anything. And then for the remaining properties, the landlords will have a price cap of £10,000 within which they will need to reach the standard. And that probably means loft insulation top-ups, cavity wall insulation, maybe suspended floor insulation if it's accessible from below, and maybe and double glazing if it can be afforded within the £10,000. So that is fairly light touch stuff, really.
And I think, I mean, reading through some of the documents, there were some proposals in there. I think that you would get, there was a bit of a points-based system, and if you had clean heating, you would get more points for that. But again, it's all very, it sort of was one of those things where it was put up for consultation and there were some ideas in there, but they didn't actually put forward the sort of pulled back the proposals on it. And so we're just waiting to actually see the detail on it because you
Yeah,
can't do a lot of the heat and building stuff unless you've reformed EPC at the same time. Because currently EPC, of course, is not a good measure for, um, energy efficiency.
true. It's quite a blunt. But EPCs were never intended to really give advice. They're only really
Yeah.
a rough cut compliance tool. But with the new system coming in next year, the EPCs will be probably more expensive to get because they're going to be more complicated to buy, more complicated survey to perform, but they will give a better insight into the heating system, the fabric performance, and also even just measures like is the property ready to interact with a smart energy system like smart meters and so on. So a lot will change.
Yeah, no, I think that's right. If anyone else has any questions, feel free to pop them in. I think we've covered most of things that have come in. Oh, we did have one come in from Cameron. Are there any examples of A2W outdoor heat pump installations, wall mounted or otherwise, in tenement flats above the ground floor?
There are. So that picture I showed of the two heat pumps in a corner outside the rear of a tenement flat, that was covering the ground floor and first floor. So a ground mounted, there's definitely precedence of ground mounted air to water heat pumps supplying the first floor. And I'm not really aware that there's any barriers to supplying even the second or even the third floor. But there's not so many examples to look at. Um,
And that's part of the problem right now, isn't it? I mean, you must find that difficult, is that the amount of examples of heat pump installation in tenements is small, so the sample size is small, so it's really hard to get a sense.
yeah,
Would you agree with that? So,
that's right. I mean, the systems are all there, all the technology is out there. There are installers that are willing to install, but there's just a lack of customers. So we're stuck in a kind of loop that consumers don't really have the confidence because they don't really see enough precedence. And so therefore the installation companies can't really build up their businesses without having customers. So that's something that Local Home does, that we do arrange from time to time open home visits where people can come and see visit one of our members or one of our past customers and see a heat pump. And we do have examples of air to air on balconies, air to water ground floor flats. But for higher levels, like it's entirely possible, but we just don't have any examples. Sorry, Cameron.
yeah, yeah. The somebody had a question. I mean, can you talk a little bit about sort of the health advantages of switching to clean heating systems from a boiler?
So, so with so one of the okay, so there's maybe two aspects to that. One is like a direct impact of moving to a clean heating system, and the other one is indirect. So the indirect one is that we maybe three impacts. Indirectly, we often most people getting a clean heating system like a heat pump are doing that as part of a package of measures. They'll also be looking to check whether they've got any there's obvious insulation upgrades to make, like floors and lofts, draft proofing around windows, around um, bare floorboards, and that will bring a comfort benefit. We'll also introduce, with our customers, we'll always recommend a ventilation system if you're introducing some draft proofing. So a ventilation system would mean extract fans from kitchens and bathrooms, which will draw air through the trickle vents in bedrooms and living rooms, and that means you've got good quality air all the time, no matter how windy it is outside. At the moment, many traditional tenements, certainly the quality of the air is dependent on how windy it is, basically, and the heat and comfort depends on how windy it is. So that's an indirect one. A direct one is that, as I said, most heating systems with gas boilers in the UK, for historic reasons, are undersized. So the radiators simply don't have enough capacity to supply enough heat. So there's certain rooms that stay underheated. And the third reason is that when you move to a heat pump, usually the heating is on more consistently, especially with an air-to-water system. The heat pump will operate most efficiently if you're maintaining a level of comfort around the clock. So maybe 18, 19, 20 during the day, and maybe only 2 or 3 degrees below that at night or when you're out. And that has those two effects of having the right size radiators and having a more consistent heating means that surfaces in the property stay warmer and drier. You're less likely to get mold. And the big health risk in our buildings that we are really looking out for in retrofit is the risk that damp will form, mold will form, and then when mold is there, black mold, the spores are extremely hazardous to human health. If they get in your lungs, for vulnerable people and children, they can be extremely bad for human health. So it's a complicated system in buildings, but that's how we hope to see impacts from clean heating on health.
We had a question from Thierry on as far as sort of, and this is a constant one that comes up, I think, with conversations we've had and others about the space available in tenement flats, tenement buildings to put in individual heat pumps. So, for example, somebody's asked a question of how you'd fit heat pumps in tenements, and they're close. They have 10 flats. Would that be something that you're stacking them up, or are you spreading them out? I mean, is that how? And then, of course, there is also the point that was raised too, which is that you need to have the space to store the hot water. Is that?
Yeah, that's right. So if we're looking at individual air source heat pumps, which is the system that's most viable, it's very difficult to organize a network system as a building or a neighborhood or a community, um, because those networked ground source heat pumps are more expensive per property at those smaller scales than a boiler or an individual heat pump or waiting for a heat network, a wide area heat network. So if it's ground mounted, those can be in a little sort of farm of in fenced off area of heat pumps. They can be stacked. So I think I've seen 2 and even 3 heat pumps stacked on top of each other. So each flat's individual heat pump is out there, but that can look quite unsightly. And I think that's aesthetic barriers are one of the main constraints. It's difficult to find consent amongst all your neighbours or enough of your neighbours to locate heat pumps in the back court. If you've got a flat roof, it's relatively doable and certainly quite common to put heat pumps on the top on a flat roof. So we've got a building we're working with, which is a 1970s construction with a concrete flat roof. The roof needs to be resurfaced. So okay, well while we're up there, what can we do about the heating system, which is storage heaters? Nobody in the building likes the storage heater, so they're quite open to making a bit of an investment on the heating system, and in that case, we're putting them on the roof. So not sure I asked Tier's question. Oh, then hot water. So you would, yeah, if with a heat pump, it is necessary to have to store hot water, or at least a little bit of hot water, because heat pumps can't produce uh, hot water at the rate you would need to fill a bath instantaneously. So the system I showed there is a much smaller cylinder. So traditionally you might be used to seeing cylinders that are, kind of 150, 200 liters, quite big cylinders that need like an airing cupboard or something like that, need a new dedicated space. But there are newer systems where they need a buffer. So there's just enough hot water in there to get the tap going or start filling the bath while the heat pump kicks in. if you think that a shower, an electric shower, is a 7 kilowatt shower typically, and a heat pump for space heating requirements is usually a 7 kilowatt heat pumps. So the heat pumps are actually powerful enough. There's just a bit of a time lag. So there's better and better systems coming out. There's also thermal storage. So phase change materials. There's a company in Edinburgh called SunApp, which makes a compact hot water storage system, which is 40% of the size of an equivalent hot water cylinder. So there's more and more options at making it possible to fit into a flat. The biggest problem is when you're willing to undergo the disruption for that change. And it's the best time is when you're moving in or when you're redecorating or getting a new kitchen or something like that. It's the timing is the constraint more than the actual space.
And some of that too is also like getting things as a, I mean, one of the things that Under One Roof talks about is trying to get as much work done at the same time. I mean, one of the biggest costs when we're talking about repairs, for example, is scaffolding, right? And so if you can get scaffolding up and you can do 2 or 3 repairs to the building, or works on the building, yeah, it's going to cost you more in the sense that you've got to get it done now, but in the long term, actually, you're saving some money um, uh, in the long term. So if you can get some of that work done, like
Yeah, that's right.
collectively with something else going on, yeah.
Because the bar, your whatever heating system you have at the moment has a lifespan. It will need to be replaced at some point. So if you can start planning now for a better system whenever that's ahead of that your existing heating system failing, then essentially what a new boiler 3,000 will take that off the cost of the heat pump. It's no your
Yeah.
heat pump system is no longer 15,000, it's 12,000. So because you're going to have to incur that cost anyway. So timing and planning ahead is really important here.
One of the things that's been brought up too, as far as district heating or shared networks, is the ability to um, individual meter those properties. I mean, is that technology exists now? So if you had a network system or you're in district heating, that you can meter individually per flat.
Yeah. So so if you're in those district heat networks, those are the ones that are likely to be driven by the local authority as big infrastructure projects. They have that interface unit I showed has a meter in it, so it's meters heat on a similar basis and similarly accurate as your electricity meter, your gas meter. If you're looking to build, if you have an opportunity and the wherewithal to organize a communal heat network or a small scale network for your building or your block or your street or your campus, then there's 2 ways to do it. Either you've got a network ground source with a service fee, and there are companies that will uh, oh, I've lost my train of thought there. So there are companies that will provide the network as a service. So they'll take on the cost of drilling the boreholes, building the common heat source, whether if it isn't boreholes, they'll run the network up to your property. Then all you need to do is pay a service charge, which is works in a similar way to your standing charge for gas or electricity, but probably higher. But then you also have to pay your electricity consumption for the heat pump that's in your property. So most of the operating cost is the electricity for the heat pump. And then you're basically paying off the infrastructure cost of building that network over a long period of time through your service charge. So that
Mm.
I have not seen an example. I mean, I hope there's examples out there that I haven't seen, but I haven't seen an example of community-led um, networked heat pumps of that kind for domestic properties for flats. I'd
Mhm.
love to hear about them if someone knows one.
What about a couple of people have mentioned about the possibility of installing heat pumps in the attic or below the roof? Um,
Yeah, like in theory, it's entirely possible, and I've seen proposals for um, attic mounted heat pumps where a fake dormer is built, and instead of windows, it's got ventilation grills, and the heat pump is inside that sort of fake dormer roof. Um, and there's also examples in Netherlands. It's very common for heat pumps to be designed to sort of slot into spaces in the roof, so they sort of crane them in, drop them in the roof, and so they vent to outside, but they can be serviced from inside the attic space. So again, all these systems are kind of possible and doable. It's just not enough demand. So because there's no demand, there's no supply. So this is why we need a bit more of a. We do need coordinated approaches, um, for houses, not just
Yeah.
for flats. Yeah.
And as somebody's pointed out, there's a bit of I mean, there's the issue too about the ownership of the space of the attic space, and that's something you definitely want to be checking your titles on, and checking to see whether that's a communal area, and therefore if you need agreement of other owners to be doing
Yes.
work in there. This is a very good possibility that you might be. I mean, the titles are different on this particular issue. Usually, the roof and the structure bit of what's holding up the roof would be a communal area of the property, and the space below it might be the sort of the technically the owned bit of the flat on the top, but the top floor flat. But that's something to definitely you want to check your titles with before you sort of start taking a close look at that as well.
That's right. And
Um,
Terry makes a good point about noise, but also vibration. So, but if it's located above the kitchens, then it might not be so bad.
yeah. I mean, finally, just to wrap up, we've had some great questions. I mean, as we constantly talk about, and we've been doing this for a number of years now, like technology is always changing, right? And things are getting better, which is great. But at what point do you sort of, I mean, do you have any sense of like, at what point you just sort of like, okay, the technology is finally caught up. Now is the time to actually pull the trigger on this.
Um, I think technology is getting better. Like there's all kinds of new gadgets that are making the job of designing a heat pump system and installing a heat pump system, and also for heat networks, by the way. There's better software to plan out the the capacity required for heat network, better software for a plumber to figure out the piping and radiators required for a heat pump. Though that's those new gadgets like the hot water cylinder that fits underneath your kitchen worktop. And there's also automatic systems to automatically balance all the radiators and avoid pipework upgrades. Like widgets like that are coming along, and software. But really, the technology's there. What we've got is a demand problem. Like, it's not a technology problem, it's not a supply problem. There's just not enough demand, and this is why it's frustrating to see the Scottish government has watered down its original intentions to drive the transition to clean heating and instead make it a target, a sort of aspirational, voluntary kind of change. Yeah, I don't really have a good answer for that. It's really, I know intermediaries like us, and there's other organizations like Local Home that are willing to advise motivated homeowners, and we're willing to go out and find contractors willing to serve motivated customers and explore new technology. And there's good installers out there that are experimenting with tech out there for the right customers. It's just not enough customers. So yeah, sorry, I don't have a nice answer to that question.
No, it's fair enough too. And I mean, and that's the sort of thing. Things are moving forward. District heating is moving forward, but it's slow, and it's going to take a lot. When we talk about district heating, you're talking about massive infrastructure projects that'll be generations of change. The effects on that will affect multiple generations to come. The installation of district heating. We did a webinar on this a couple weeks back, I think it was, and yeah, I mean, you've got European countries as the examples of that, but it took them decades to install those projects.
Hmm.
So, and that's probably what we're looking at here as far as sort of district heating as well as finding, Scotland wide. So you're obviously going to be more likely to see it in the bigger cities first, just because there's
Yeah.
more in direct impact on that. But yeah, it's going to take, it's definitely going to take some time and some innovation to sort of to come across on that. But there are options available and availability available, and we have someone like Chris that can help you if you want to explore it more. Thanks, everyone. It's been a fascinating conversation as always with Chris. Thanks so much for joining us today. And we are constantly having webinars on various topics, including retrofit. We've got, in fact, one tomorrow on toolkits for retrofit that we are hosting at noon as well. So if you go onto the events webpage of Under One Roof, you can sign up for that. It's another free hour-long discussion. But until then, and of course, if you've got any questions about anything you've heard here or about organizing tenement maintenance or management, you can go to the Under One Roof site. We have an Ask an Expert section to it, and that people can put in inquiries and such to be able to do that. Chris, do you have the feedback as one of your slides? I think
Yep.
I saw that, but yeah, could you pop that up on the screen?
Yeah.
The final thing would be is if you could, we are funded by the Scottish government and local authorities, and we rely upon feedback to let us know what we're doing wrong, and then when we're doing right is to be able to sort of pass that on as well. So if you could just fill out that, use that QR code to fill out. It's only about a few questions. I think it's only 4 or 5. It will take you under a minute or so, but any feedback you can provide us would be fantastic. So, well, thanks very much on behalf of Chris and Under One Roof. Thanks for joining us today, and hopefully we'll see you at another of our webinars soon. Have a good day.
Bye bye.